Okay, so this is the section on the chain rule. The chain rule is a very applicable rule to a lot of complicated derivatives. Sometimes you'll have a derivative of a function which looks like it could be one function buried inside of another. Those functions which look like that are called composite functions. And what that means is if you have a function which is a function inside of another one, so you have some f of x, but you also have some g of x, which could be plugged into f of x, and you get out a result that looks kind of like this complicated function, then that's what a composite function is. And so we have this definition written as m of x equals f of g of x. So this is the idea that I was kind of telling you about the Turduncan of functions, where you have your g of x plugged into your f of x, and you end up with this result here. It can also be written as m of x equals f of g of x. And so this is kind of a silly little acronym of FOG, but the O here is sort of a mathematical symbolism to say of, just sort of the same way that I stated it as f of g of x. And so you're able to kind of write it this way as well if you wanted to use a different notation to kind of denote the embedding of one function inside of another. But this allows for us to kind of look at what's happening to more complicated functions and be able to dissect what's happening into individual parts and then work with it that way. So if we look at what the chain rule is, the chain rule is a way of differentiating these composite functions. So say that we have our composite function m of x equals e of I of x. Then we can say that m prime of x is equal to e prime of I of x times I prime of x. And this is the main statement of the chain rule, is how we kind of get that derivative there, where it's the derivative of the outside function, and it still contains the inside function inside of it, but we also have to multiply by the inside function derivative in order to get a result at the end of the whole composition there to be the sort of adjustment for what the derivative is. And so this is just a rule that you can use for these embedded functions, these composite functions. And you can also restate it as y equals e of u and u equals I of x, which is just a restatement of the initial conditions that we had here for m of x equals e to the I of x. And if you have these cases here written out this way, you can use the differential notation to come up with dy over dx equals dy over du times du over dx. And so this is how you can kind of approach the chain rule if you wanted to look at it in such a way that you're able to split it up into differentials and look at the individual derivatives for these components. Find out the du over dx part and find the dy over du part, and then that would solve what the whole dy over dx is. All right, and so now we know kind of what the chain rule is, and we've talked about it a little bit. We can kind of take a look at what the chain rule applied to different functions would give us. So here's some general derivative rules using the chain rule. One of them, the very first one, is called the general power rule. And what this is it's the derivative of a function to the nth power would come out as n times f of x to the n minus first power times f prime of x. And so you would find the derivative of f of x and you would multiply it by this almost power rule of function. and you would come out with this result here. And so this is just applying the chain rule to f of x inside of x to the nth power as another function. And so if we had g of x equals x to the nth power, and then did the derivative with respect to x of g of x f of x, this is basically the same kind of idea as that. And so this is the general power rule. This is the result you would get out, and this is how you can calculate it. So if you ever run into a situation where you have this embedded function f of x inside of an x to the n power function, this is the derivative for that. Now, if you ever have an f of x buried inside of an ln of x function, we also have a way to solve that using chain rule. And so if we apply the chain rule to ln of x of f of x, then we can get out this 1 over f of x as our initial kind of derivative of that ln function. And then we can also multiply by the interior derivative, so the derivative of that f of x function, to get f prime of x over f of x as our final result here. And this is a very nice, a very neat kind of result from using the chain rule on this type of function, is finding out that you can take the derivative of the function over the function itself, and that's just the derivative of that ln of f of x function. And so it's a very nice, very neat kind of result to get out of that. We can also do the derivative of e to the f of x, where some function f of x has been embedded inside of the exponential function. You'll usually see this with f of x being a polynomial of some sort and trying to solve for what comes out of that. The rule in this case is f prime of x times e to the f of x. So since e to the x is equal to e to the x when you take the derivative of it, that's just what we get right here for that first part, where we take the derivative of the outside with respect to the chain rule. And then we have to multiply by the f prime of x just to get that last part of the chain rule, where we're adding the derivative of the inside function, or of the embedded function inside of the composite function. And we get this whole term here as our end result, f prime of x times e to the f of x. And this result can be very useful in differential equations, specifically because of just relations and how they get used with y or functions equal to the derivatives in that class specifically, or in that field. And so if you're ever interested in it, this allows for the derivative to be equal to the function itself in some manner, because this f prime of x just becomes what your coefficient would be in those relations. And so that's a nice, neat way to find solutions to some differential equations, is just by using this relation. So if you're ever in that class, you can always kind of point back to this and use this a lot in those situations. So, all right, that's about the end of this section for the chain rule and topics involving it. So I hope that this was informative, and I hope to have some more videos up later, but this is about what I have for you guys now. And hopefully you'll be able to get through some of the problems in the book and problems for the class using the stuff that I've given you. So, all right, I'll talk to you guys later.